Hi guys. Sorry, there has been a technical glitch. I've been having it since morning. So I'm glad to see you guys and thanks for your patience. So let's see, let's wait another maybe 2 to 5 more minutes and see if more people will come in. If the rest, I think we are 17 now. I need 5 more people.
So we need the writing balance precipitation ones, not the other one. I saw there was an opposite one.
I guess we can go ahead and start. The lab today is really probably very short lab, and we're going to be doing the writing balanced precipitation reactions, which is number 2.2 of the reaction kinetics. And it is a follow up from what we did on Thursday, where we saw reactions occur from the color change or present or absence of color. So this time we are just doing 3 different reactions. Of course, in your lecture today, you talked about how you can uh, determine that a reaction has occurred by the presence of precipitate, the evolution of gas, the the presence of heat, and virtual lab has its own way of showing us uh, evolution of gas and evolution of heat. But the precipitation is no problem because you're going to see it occur. So in this lab, we're going to be looking at how silver nitrate, lead nitrate, and antimony hydroxide, how they react with a common reactant, sodium carbonate, and sodium chloride, and then sodium sulfide. So what you're doing in the lab today is to follow steps 2, 3, 4, and 5, and then you observe what has happened. You describe the color of the reaction you saw, and then write a correct, balanced, net ionic equation for the reaction. And you know that if a solid is produced, you do not break up that solid into ions. But if you saw a solution, then you can break up the solution into ions. And that's what you're going to be doing in the lab today. Number 5 is basically like double displacement reaction. And you add this sodium sulfide into the antimony hydroxide, and you observe what happens. You see that when you add the antimony hydroxide to the test tube, it will be like it is really a precipitate.
Okay, question.
Uh-huh.
So you said you're reading number 5, right? On the 2-2?
Yeah.
Okay, so then can you say the names? Because I see SB3 and then the sodium sulfate, I think, or sulfide. But I'm not sure exactly what names you're talking about or mentioning.
Okay, Chanel. Let's start from number 2 again.
Okay.
So in number 2, you say you can click on the bottle of silver, which is what Ag plus means. And that particular Ag plus bottle contains silver nitrate. All nitrates are soluble, so it's a clear solution. And then when you do that, you drag it to the blue rack, and you do the same thing for lead nitrate. And since all nitrates are soluble, lead nitrate will be soluble. And so you look at it, it's like a clear solution. And then you take it to, you then click on the bottle of antimony, which is Sb3 plus hydroxide. And antimony hydroxide should be a white solid. And so when you click, you're gonna see the white compound in the test tube. Okay, so now it goes for the individual test tubes. It says, moving your mouse over each test tube in the test tube rack will allow you to identify on the TV what you are looking at. And the TV is that screen that is to the top left-hand side of the lab.
Okay.
So then it says for you to start by placing that, you place this silver nitrate test tube back in the metal stand. The stockroom will light up, and then you click on the sodium carbonate bottle, and you see something happen, you describe what has happened, and you write the correct balanced net ionic equation. I think this is, I think you either talked about it today or you started talking about it last week. What I have is the old textbook, so the chapters will not be the same.
So if I'm looking at the worksheet, and just because I just need to clarify everything. So if you were to first grab, let's say the AG or the silver, you said?
Silver.
Yeah. So if you grab the silver, on the list on the paper, which ones are we supposed to mix in with it first?
Okay. So all right. So and I can understand the confusion, because what it's telling you is to do the silver nitrate, you add the sodium carbonate to it, and you see what happened. And then you grab the lead, which is the Pb, and you add the sodium chloride, NaCl, on it or into it, and you see what happened, and you describe it. And then the third thing you do, which is number 5 on the list, you grab the bottle that says SB3, and that particular bottle contains antimony hydroxide, which is a white solid. And then you place it on the metal rack, and you add sodium sulfide, and you observe what happened, and you write what you saw. And for the 3 experiments, you write the ionic equation. I have, let's see. I think I have the 4th edition of your book with me. The current edition is at Harvard College, and I can't get to it. But this particular chapter, the information you are doing is identified as classifying chemical reactions.
Do you have to write down either whether there's no reaction or anything for either?
Actually, in each of these things, that a reaction occurred.
Even
you're gonna see a change in the original solution.
So you don't add, do you add each chemical in it separately, or do you put them all in one tube?
No, it's one on each. You add the sodium carbonate on the silver nitrate. You observe what happened. You write the balanced equation, and then that's it for the silver nitrate. The next test tube should be the lead nitrate. You also write on it, which is what it tells us right there on number 4. You add sodium chloride solution to it. You see what happened, and you identify the color, and then you write the balanced ionic equation. And on number 5, you do this the same thing for the antimony hydroxide. The tube is on the metal stand. You add sodium sulfide there, and you write what you observed, and then the ionic equation. And when you finish those 3 operations, the lab is really done for today. Okay.
Yeah, I'm still a little lost, but that's because it's all on the computer.
What are you lost about?
I'm still just trying to make sure how to do this, because I can see adding in, I forgot what it's called, but the P.
No, Chanel, don't forget what it is called. You're gonna know what it is called.
Okay. Let me see. Oh, okay.
Which number are you talking about?
Well, even number 2, just to even start from there, it's complicated.
Well, actually, Chanel, number 2 is really basically a repeat of what we did last Thursday.
Okay. Oh yeah, the lead ion. Okay.
Okay.
Yeah.
Can you pick up the test tube and place it on the metal stand?
Yes.
All right, and you see when you did that, the stockroom lighted up.
What? Yes.
All right, from there, then you can complete step 3, which means you click on the sodium carbonate if it lets you. But the way it is written, it means you will do all of number 2, which means pick up the silver nitrate, add the lead nitrate, and then the antimony hydroxide, and then place them on the blue rack. And then you go one by one and do number 3, 4, 5.
Okay, let me see.
Professor, I have a question for number 3. It says write a correct balance net equation for the reaction. Is that what we write that's on the TV screen or monitor, or is that something different?
That's a good observation. Who is this?
Adriana?
Okay, Adriana, yeah, that's a good observation. It really, that TV monitor really tells you the products of the reaction. So if they are together like a compound, it means that there is a reaction.
Right.
And then the next thing it will probably show you there is the other thing that didn't, the ion that came out from the displacement reaction. So if you were to write the ionic equation, the silver carbonate is a solid. And so they will go together. It cannot separate into ions. But the sodium and the nitrate will be in solution form. That is the one you're going to put into ionic equation.
So we make the ionic equation. It's not on the lab screen.
No, it's not. You might see sodium plus, but there is something else it hasn't told you, and that is what you, as the student, will decipher.
How do we do that?
Well, you started with silver nitrate, which has 2 compounds, right?
Yeah, can I share my screen so I can show you where I'm at right now?
Okay, yeah, I wanted to share screen. Okay, go ahead, yeah.
Share. So this is what I have. So I got a light brown precipitate,
yeah.
Yeah, and then that's the first part of 3, and it says write a correct balance net ionic equation. And I'm asking, it's not this, correct? You're telling us that we need to.
No, this is telling you that this is what happened there. Silver carbonate.
Right.
Is the product. That is what is in the precipitate. This thing here.
This part here is what's inside. Right.
Yeah.
There. Okay.
All right. So, and what is telling you there, it says / silver oxide. Okay. So it's telling you that it could sometimes the silver nitrate could also decompose into silver oxide and silver carbonate, but what we are expecting in this reaction is the silver carbonate and the sodium nitrate, which will be in the liquid form. And so the sodium nitrate is what you're going to write the ionic equation for.
So are you supposed to mix multiple items on the actual directions in one test tube?
I can show you right now if you like. So I can just start over. So basically the first set is just telling you to pick up the test tube in. And then it's asking you to put the silver, so the Ag+. So you put that.
Yeah. And what do you see? A clear solution, right?
Right.
Yeah, I added the silver. So this test tube is ready, and then you put it to the side.
Good.
And then you grab another test tube, and then it's asking to repeat it for the lead nitrate and the Sp3. So I'm gonna add the lead, which is this one, and then that one's ready. So you put that one to the side, and then you repeat it for the last one, which is this one here.
That's antimony, yeah.
and then put that to the side. So that's
All right,
it
so
number
for
2.
that antimony, is it a clear solution?
No, it's a white one.
It's a white, is that a white solid or white solution or white what? It looks like the antimony hydroxide is a white solid floating in its solution.
Oh, okay. So it looks like a white solid.
Yeah, and so then you start again now to number.
So number 3
Number
is
3.
to take the silver tube in the metal stand, and then to add. I'm sorry, Professor, I don't know the terms yet.
But no, I want to hear. I want to hear the term. I want to hear the name. What does Na stand for? You forgot that, huh? Sodium.
Okay, so
okay, so what does CO sub 3 stand for? Carbonate.
So sodium carbonate.
Sodium carbonate. So you add the sodium carbonate.
Yeah, so I click here, and that's what got me the light brown precipitate. Precipitate.
Yeah. All right, so it gives you a clue that what you see there is that sodium carbonate is a solid.
So this here's a solid.
Yeah. So okay. That is the one that you write Ag2CO3 in subscript small s, which means solid. Then the next thing that is in there will be sodium nitrate. And what is telling you there when it said sodium superscript plus is that when the sodium is displaced from the nitrate, that it did not combine with anything, it becomes sodium ion in the reaction, the right-hand side of the equation. Okay, so you have very well described what you saw, and then the thing then will be to write a correct, balanced, net ionic equation for this reaction. What do you mean by correct net ionic, which means the number of, say, sodium in the right-hand side of the equation must balance the number of sodium in the left-hand side of the equation. And if it cannot go from Na super 1 plus to Na super 2 plus. The charges should balance and the compounds should also balance. That's what it means by correct, balanced, net equation for this reaction. Okay, so Adrian, let's go to the next one. Are you clear with these two?
No, to be honest, I'm just confused what to write. So I know you said like for the silver subscript 2 and
carbonate.
Carbonate. And
yeah,
then
carbonate.
And then parentheses S for solid, correct? That's what you said. Is that the correct balanced net ionic equation for number 3?
No, that's not. That is this is a replacement equation. That in this particular reaction, the carbonate is replacing nitrate. Okay, so the carbonate replaces nitrate in silver, and you get silver carbonate, and the sodium joins with the nitrate, and you have sodium nitrate. And from your lecture, you probably heard that all nitrates are soluble. So The sodium nitrate is the one then you're gonna have in ionic equation, which in principle will be Na plus Na plus NO3 minus. Then you balance the number of atoms on the left and the number of atoms on the right. Does that make sense?
For the solution that I don't know what it is, but you have in the actual test tube holder?
No, Chanel, I don't want to hear, I don't know what it is. You are a chemist. You want to learn what it is, and I can accept pronouncing it wrong, but we should try and know what it is.
Okay, so the solution that's in the test tube holder is it silver with the carbon dioxide together?
Carbonate together, not carbon dioxide. You see, it is CO3 and not CO2.
Okay.
CO2 is carbon dioxide. CO3 is carbonate.
Okay, but where did she get the CO3 from? That's what I'm looking for.
Yeah, you see what you added there. If you do you see Adriana's board?
The one on the screen.
The lab. Okay, you see where that lab bench next to the red canister.
Yes.
You see where it says Na sub 2 CO3.
Oh. Okay. Yes.
So, and when you go in there with your cursor, when you go there, it will show something like a syringe. You click on it and it will add it to the test tube that is on the TV screen.
Okay.
You want to try it?
Yes.
All right, try it on. I don't know if you can do that with Adriana's lab bench, but try it.
I can stop sharing my screen, and then Chanel, you can share your screen. So
no, I don't want to show my screen because you guys
I'm
are
telling
supposed
Chanel
to do
she can share hers.
Yeah, Chanel can show her own screen. If it was a very complicated lab, then I can help by showing my screen. But this is, like a recipe. Maybe Chanel doesn't cook. Chanel, do you cook?
I try. I actually like cooking a lot.
So you know how to turn on the stove, right?
Yes.
All right. And so you want to make that pot of beef stew from the scratch. And you read recipes one after the other, right?
Yes.
All right. And so in this instance, it tells us the recipe, so to speak, is to get the test tube, put in either the silver nitrate, the lead nitrate, or the antimony hydroxide, and then you set them aside. And then you come back and work with each of those one by one in number 3, number 4, and number 5.
Okay. Okay.
Just like Adriana did, you can show me your own lab bench.
Okay, let me see. Okay.
Good. All right. So you no.
So I have these two so far.
Oh, okay, you have them already.
Yes.
Okay, so you're gonna pick up the one that is clear. Let's start with the silver.
So this one?
No, that's not that's the antimony hydroxide. Okay. Okay, what does it say?
This one, I just put the silver in it.
Okay, good. All right. Now, and the thing is still lighted. Let's see if it will let us add the sodium carbonate. Did you remember where we saw the sodium carbonate?
Here.
Good. All right. Click there. and you see a change.
Yes.
All right, so what is going to ask you is ask you what, what color is the precipitate? A precipitate, the weather, the people who do the weather usually they say rain, but
Exactly.
actually the technical word for rain is precipitation, which means something that is falling down.
Okay.
So when you added the uh, sodium carbonate to the solution of silver nitrate, you see a precipitate form, which means a reaction has occurred, producing a solid. And ordinarily, if you put that tube in a centrifuge, it will form a pellet at the bottom of the test tube.
Solid, right?
Yeah. Okay. So you describe that thing you saw, and what he's telling us here is that the compound, the solid in that particular test tube could be silver carbonate or silver oxide. And that is what you're not gonna make you as the student chemist will decide, is this going to be silver carbonate or silver oxide? Well, you added sodium carbonate, so it looks like what is going to be trading places will be the nitrate and the carbonate. So that product there will be the Ag sub 2CO3, which we call silver carbonate.
Okay.
And then the next thing that will be there will be plus sodium nitrate. So the silver carbonate is a solid, which we usually represent as S, and the sodium nitrate will be aqueous, which we usually represent as AQ. And that one that is aqueous, we then break it up into Na plus and NO3 minus.
Okay.
And then you balance the ions and the atoms in the right with the number and ions from the left.
Okay. 1, 2, 2.
Is that reasonably clear?
Somewhat. I just can't really understand it. I'm trying to make sense of how it even balances out. But yeah, I mean, it's just time. I'll get used to it.
But you printed out that 2-2 writing balance precipitation reactions?
Well, I couldn't print it because I don't have a printer.
Oh.
Yeah, but I have it up on the screen. I look at it.
So what you're doing is moving from the lab to the instruction.
Yes.
All right. So you are a younger mind. If I do that, it means sometimes I forgot what I see.
Okay.
But you are younger, so you will not remember everything, even to this 10th click. Okay. Any other question from any other person?
Professor, I think one of my group members is trying to get in. She says she sees the window that the host will let them in.
Oh, okay. Okay. Is that Brody and Haley?
Them too, but Ezra's trying to get in.
Okay, I think they should be able to get in here. I don't know why this is behaving like this. I thought you guys wouldn't show up today, but I'm glad you guys had the patience.
We thought you weren't going to show up, Professor.
I've been there since the 3:25. So my computer has been acting up since the morning. And if the whole thing is clear to you and you do all the clicks, is probably, I counted it is 3, 4, 5, 6, 7, 8, 9. If you did all the 9 clicks and you got to number 5, it means you have done the lab, and then you take time to write the observation and the answer, and this is what you hand in. What some students did in the morning was to write out number 3, number 4, and number 5, type it out, and then they submitted with their names and section. And I think you should do that because some of us write big and some write little. So then we try to squeeze it in there and it becomes illegible. So why not just, since you have basically 36 hours, you take it to write it out and hand in 1 sheet of paper, not 2 or 3.
When we submit the answers to you, where do we send it to?
You're sending it with your group to the inbox. The inbox in the Canvas.
Okay.
Professor, there's one more student trying to get in. It's saying waiting for a host to connect. So if you can get him in, I've got to say his name again. It starts with an E.
I think he should be in by now.
Yeah, he said it says waiting for the host. Yeah, I don't see his name up there.
Yeah, he should be there because I don't see anybody waiting.
He said when he clicked on the link, it takes him to a screen that says the host will let you in the meeting soon.
Yeah, then I'll click on the thing to let him in and it doesn't show him there.
Okay.
The thing is telling me that there are 17 participants, which is what I have here. And it should, if we're still waiting, it should have said admit.
Okay, hold on. I'm gonna tell him to try to press on the link again, close the screen, and try to press on the link.
Okay. It's funny though that even the pronto thing doesn't work for me. And yet I'm the teacher. I was supposed to have everything under control. I
right. How do we unify our lab answers? Where do we submit my lab information?
It says for me to find a participant, and I clicked on that, and nobody is waiting.
Okay, I have to wait till he.
If he comes back, and I left that thing open. If he comes back, I'll see it.
Okay.
So thank you.
No problem. I'm gonna mute my mic.
Okay.
Professor,
Yeah.
question. The assignments that you recently graded, I think it was earlier today, are those out of 20?
The what?
Are those assignments out of 20 points?
Yeah, these are, yeah, okay, thanks for the question. These labs are out of 20 points, and what I'm looking for is whether you balanced the equation with respect to the elements. In other words, do we have as many silver Ag on the left-hand side of the equation as we have on the right? And the charge, do you have Ag plus, which will never come to be Ag2 plus? In other words, do you have the right charge? That is, those are the things that I am looking for. And for this particular number one, when you reacted silver nitrate with the sodium carbonate, you have a white precipitate, and not just white. I said it last time, and some people still just describe the color without the words precipitate. They're not the same thing. So if you have that white precipitate, when you wrote the name or the formula silver nitrate, did you put in the letter S in the subscript? So those are basically the three things I am looking for, which could get you a score from anywhere from 20 if you are perfect, to maybe 9 if you missed the plus signs and the S signs and all those things.
Okay, thank you, Professor.
Welcome.
I also noticed we thought that you were giving us grade, like only some students' grades, but I think we thought that because you have the assignments listed under our names, correct?
Yeah, the names. I guess that is my naivete as far as putting groups are concerned. The names, I'm looking at the names that are on the extreme left-hand corner. That's where your names are listed. Ignore the labs that is on top. That shouldn't be there. What should be there would have been the labs that have been done. So I am looking at it as, say, Alicia Gomez in lab number 1, she and her group maybe scored 100 or 90 or something like that. Everybody in the group, because everybody in the group was listed. And then the second will be the next lab, the third lab. And now from last week, we did the next 3.
Okay, I get it now. Thank you, Professor.
Right.
Professor, I'm trying to see where you're talking about, because when I go to grades and I see my name, Shantae, I don't see anything filled in stating my grade.
Yeah, I know, Shantae. You're probably looking at the top row instead of the left-hand column where your name should be. Then you read across.
Well, am I supposed to be on grades or no?
Yeah, it should be on grades.
Okay, and I'm looking, and oh wait, hold on. Yeah, this is your section. So yeah, I'm looking at it right. I don't see nothing on the left-hand corner. I just see my name is under Bernal. Sorry if I said it wrong, but a lot of us don't have any grades.
Well, in my Canvas shell, everybody has a grade.
Yeah,
I can help you with that, Shantae.
Okay.
Okay, so what he's doing is you can only see your grades. That's what it is. Each assignment is listed under someone's name instead of the actual assignment name for some reason, but the grades that are there are for you.
It's listed under someone else's name?
Yeah, I don't know why. The assignment names are just listed under someone else's name.
Oh, yeah, because I see the assignments listed under other people's name. And I'm
Yeah,
like,
she's
okay, is that
basically
my
trying to say like the score in the top right is your score, despite it's
score?
only
And the
yeah, like
the total where it says 356, that's my score.
Yeah.
Oh, okay. I got you.
Yeah, I can't see your individual whatever, but I can see all of you in my own Canvas shell. I can see the grade and I'll follow you one after the other to the end.
Oh, okay. Well, how do we know well, I know this is redundant, but how do you know, the points you're supposed to have? If mine's just saying 356, what is the total right now of points that we
Okay,
have?
that 356, yeah, that's a weird way of putting it. The 356 should be the total of the 6 labs that we already did.
Okay, so I have 1, 2, 3, 4, 5. Only have 5 and then 6. Yes. So I got 356, I guess.
Yeah. So the first 3 labs were worth all 100 points because of the extent of the work.
Right.
Then all the labs that we did last week were worth 20 points each, and it was graded one whether you chose a reasonable scale in plotting the graph, and does your RH, the Rydberg formula, does it have units? If it doesn't have units, you lose
Okay.
1 point. So
Okay.
if it says 356, it means that in the 3 labs that we did last week, you missed a total of 4 points.
Yeah.
Okay.
It's 4.
So now everybody knows that, like I said this time, what I'm looking for is the compounds, silver, lead, antimony, do they have the correct charge?
Okay.
Which is plus, 2 plus, 3 plus, and is the formula of the compound the correct formula? And does it have the S for solid or aqueous for liquid?
Okay.
And that's aqueous meaning aqueous.
Okay.
So those are the things that I'm looking for basically in these 3 reactions that you're writing.
Okay.
Then, of course, I talked about indicating what section, indicating the group names, and whether it is, in other words, if I'm expecting at least 5 or 6 individuals in a group.
Okay.
That sounds like a flashcard.
No, I injured myself at work, so I have now a wrist brace on my right hand.
On your wrist.
Yeah.
Oh, sorry about that.
Yeah. All bad.
That's what you get from going to school.
Yeah.
Yeah.
It's more of fighting with a dang patient, but it's okay. That's what I get for working in Psych ER.
Yeah, well, you be careful.
I will.
Don't fight with them. Try to approach them from their soft side, which
I did try. Hard. She yanked me down and messed up my wrists and put scratches all over my chest.
You have to work hard to find that soft side.
Yeah, that's the reason why I'm trying to hurry up and get my RN so I don't have to worry about it. Well, I'm getting out that field.
If you have all the experience in the psychiatric nursing, don't you think you'll continue with it?
I did at one point, but now I'm just getting old.
Oh, look at you.
It's getting old. I've been in it for about almost 10 years.
Yeah, 10 years.
Yeah, it's old now. I need something else like labor and delivery or something.
Well, think about it. The best thing that you do for not worrying about getting old is that you don't need money anymore.
Right.
You know, so you just sit home and enjoy all the money you have made. If you
Right.
see that it's going low, you put on your clothes and go back to work.
Right. Well, I'm off for a week, so I go back and modify duty Monday.
Well, okay, good luck.
Thank you. I have one question also.
Yeah.
I'm sorry, I'm very questionable today. I don't know why.
No, you're not questionable. You have more questions.
Yeah, I have more questions. I really liked it, the last reaction. That last reaction was kind of cool, but
Uh-huh.
I didn't know how to write it. I just put orange bubble precipitate, and then I put the SB2 S3.
Yeah, then you put in SB sub 2 S3, which is the antimony sulfide.
Oh, that part I didn't put. Hold on, let me find my pen. So, I lost it. Hold on one second. I don't know. I'm working with one hand. Shoot. Okay. Say it. I say it again. How did you say it?
Antimony sulfide.
And anti.
Anti-money. That is against money.
Oh, anti-money.
Anti-money, yeah.
Okay.
Antimony sulfide.
Is that one word? Or
No,
two words?
words. Two words.
Okay. Anti-money sulfide. Uh-huh.
And then the which should be the solid sub S. So basically you have SB2, SB sub 2, S sub 3, in
Mhm.
parentheses S.
Oh, parentheses S.
And then the next product of that reaction would be sodium hydroxide, which would be aqueous.
Wait. The sodium hydroxide would still be number 5?
Yeah, we're talking number 5, right?
Yeah.
Yeah, so sodium hydroxide will be the next product, and it should take the insignia aqueous, which means aqueous. And since it is aqueous, that's the one you're going to balance the ionic equation.
Okay. So I'm sorry, I write slow because I have to write with my right hand. That's the one that's messed up. So sodium hydroxide.
Mm-hmm.
And then what's the last part you said?
The sodium hydroxide will have the designation aqueous, AQ.
AQ, uh-huh.
And then because it's in the aqueous solution, then you balance the ionic equation.
Oh, now you lost me.
Balance, which means you make sure that there are as many sodiums on the left-hand side as there are on the right-hand side.
Because what I wrote was, I know this is not probably good enough, but I wrote orange bubble precipitate, then the SB2 S3 parentheses S, anti-money sulfide.
Sulfide is the name.
Yeah, sulfide, and then I put sodium hydroxide, AQ.
AQ, yeah.
And that's the whole name of it?
That is, yeah, sodium hydroxide, AQ. Then you start balancing the number of ions and atoms.
Oh, I think that's where I'm lost at.
This, what edition of the textbook do you have? Do you have any?
I have our regular textbook.
All right, so because I have a different edition, if you go to the index, you look for balancing chemical equations.
Okay.
In this edition, it's chapter 8, and the title is Chemical Reactions.
Okay.
You look at that, and it's going to tell you evidence for chemical reactions, which means evolution of gas, a change of color, and things like that.
Okay.
And then writing chemical equations, and the next thing will be balancing chemical equations. And those are the 3 things that you're doing in this particular lab.
Okay. Okay, so once we write our the what color is the precipitate, and then we'll write the compound of the name. I
Yeah,
mean,
right.
the I don't know what will we call it. I'm sorry, I don't know that.
You're right. Okay. The instruction says for you to pick up in number 2, it says pick up Ag, which is silver nitrate.
Mm-hmm.
And then in number 3, it says the silver and the sodium carbonate. It wants you to be able to figure out what are the combinations of the products.
Mm-hmm.
And then in number 4, it says lead nitrate and sodium chloride, which is NaCl. And then it says you should be able to figure out what are the combination of the products. And the one that is really complicated is number 5, which is kind of double displacement reaction.
Mm-hmm.
And that is the antimony hydroxide and the sodium sulfide, and you get your products and you describe it, and then you go ahead, name them, and then write the balanced ionic equation.
Right. So did I say it wrong? It's antimony sulfide or antimony hydroxide?
It's antimony sulfide.
Okay, and then sodium hydroxide.
And sodium hydroxide, yes.
AQ. Okay.
Yeah.
So then all I have to do is write the correct balance, right?
Yeah. In other words, usually it is advisable to first write the equation as they would occur, and then you write the balanced ionic equation.
Whew. Okay.
Because if you remember that if it is in ionic, if it is in aqueous solution, then the ions are separated, the plus and minus.
Mm.
That's probably the beginning of the lab of last week. Lab we did on Thursday.
Okay. Oh, wait, that's gonna be challenging. Okay. Okay, that's all the questions I have.
Okay, that's fine. It's just good questions.
Thank you.
You're welcome.